Hello, science class. I'm sure your heads are just spinning trying to get a handle on this science you were assigned, but hopefully, the videos that I'm going to post uh, will give you uh, some help in doing the work. Today, I want to start by doing a little bit of review. You'll remember that when we were talking about atoms, we defined an atom as the smallest particle that you can have and it still be an element. Actually, that was a part of Dalton's atomic theory, where he said that every element consists of tiny particles called atoms. You can have smaller particles. You can have an electron or a proton or a neutron, but they aren't an element. You have to have an atom, which includes protons, electrons, neutrons, in order to have an element. Now, what they found is that atoms are consist of on in its nucleus on the inside a proton and a neutron. Proton has a positive charge, a neutron has a negative charge. And then going around the outside in these shells, if you will, are electrons, and they have a negative charge. And for some reason, atoms want to keep 8 electrons in their outer shell. This is a part of the octet rule that we talked about, that atoms want to keep 8 electrons in that outer shell. That outer shell is called the valence shell, and the electrons in that outer shell are called valence electrons. So atoms want to keep 8 electrons in their valence shell, and that causes them to react with other atoms in order to get 8 electrons in the outer shell. Unless you're one of those atoms that just by nature have 8 electrons in the outer shell, and then they don't want to react with anything. The periodic table is a list of the atoms, and they are listed from the smallest to the largest according to their atomic number. Get your book and turn to page 131. You can pause me right here and go get it. I'll wait. Okay, you're back. It's good to have you back. You'll remember at the bottom of page 131, you'll see it there, is the periodic table. And what they found is when they listed the elements going from the smallest all the way to the largest, they found that they shared certain things in common, certain properties that were the same. You'll notice that this periodic table is listed in rows that go side to side. Each one of those rows is called a period, and that's where we get the name periodic table. Each one of those rows is called a period. Then you have up and down columns, and each one of those columns is called a group. Just to look at one of the elements on the periodic table, look at the top of the periodic table, and there is a little illustration there of the element zinc. You'll notice there that what we have is the name of the element, zinc, written there. We have its atomic symbol, Zn. Up in the upper left-hand corner, we have the atomic number, which is 30. The atomic number tells us how many protons are in the nucleus. How many protons are in the nucleus? And then down at the bottom, under where it says zinc, it says 65.38. And that is its average atomic mass. you'll notice that it's a little more than twice as big as its atomic number. What that means is, with zinc, you have the atomic number, 30. That tells you how many protons. And then you have the atomic mass, 65.38. That tells us that when you put protons and neutrons together and add them up, you have on average 65.38 nuclear particles, protons and neutrons together. So if you took its atomic mass number and subtracted the atomic number, that would tell you how many neutrons you would have in zinc. For instance, you have 65.38 on average nuclear particles in the nucleus of a zinc atom. 65.38. Well, if you subtracted the 30 protons, you would be left with 35.38 neutrons. Now, you're never going to get 35.38. The most of them will have 35 neutrons. But every now and then, once every 2 or 3 zinc atoms, you are going to find an extra neutron inside the nucleus. Another thing to look at with this periodic table is you have something called main group elements. These main group elements are the ones who most commonly combine with other elements. The main group elements, remember, the groups are the columns that go up and down. The main group elements are columns 1, columns 2, and then you skip all the way over to 13, 14, 15, 16, 17, and 18. So groups 1 and 2, and then groups 13 through 18 are called your main group elements. The thing that makes them all similar is this idea that in the first group, under helium, all of them have just one valence electron. In the second group, all of them under beryllium, they have 2 electrons in their outer shell, 2 valence electrons. And then you skip over to 13, under boron. Boron has 3 valence electrons, and so does all those other elements under boron. And it goes like that. In column 14, they all have 4 valence electrons. Column 15 have 5. Column 16 has 6. Column 17 has 7. And column 18 has 8. That's going to help us when we're trying to figure out what atoms react with other atoms. That's about enough for now. I'll be back on here tomorrow with another video, and this will have to do with section 7.1, the one you're working on. Remember, if you have any questions, ask them here on this group. Thanks, and God bless.